So next chapter is called value chain analysis. Again, I guess this is something that should be quite familiar in administrative sciences. However, there's a little bit of modeling that I think it's worth looking at. Mostly the model of double marginalization. So I'm just going to set the model. So you have actually two companies, two monopolies, and one is the supplier of an intermediary good, and the second one is the final seller of the good. To simplify things, we're gonna think about a manufacturer and a retailer. So you have an upstream firm, let's call it the manufacturer, and he sells something, some product to a downstream firm, which is going to be the retailer, right? And the retailer is going to sell to consumers, to final consumers, right? We're gonna take some assumptions that are going to be quite simple. First, let's state that the marginal cost for the upstream firm is constant and equal to C. Let's also state that the retailer has no marginal costs, so the downstream firm has no marginal costs, he's not producing anything, and he pays a price PT, T for transference, which is the price that he pays to the manufacturer for the product, right? So this guy is going to be selling at a price PT. So this is the same price because I'm selling my goods, my manufactured goods to a retailer. And finally, we're gonna have that consumers have an inverse demand function. Let's say something. So this is gonna be PC. So the prices are not the same, right? T is the price between the manufacturer and the retailer. PC is the price that the consumer is going to pay. And let's say that the inverse demand function is something similar to what we did yesterday. Let's say I have an intercept and I have a slope of beta, and this is going to depend on the quantity that is sold, right? So for the moment, all of this should be quite familiar. Okay, so to solve this, what we're going to do, so all of them are monopolies in the respective monopoly, and here it is a monopoly too. I need to close this. Monopoly. Oh, what's up with this? So that's the basic structure. I don't think we need anything else. And so what we can think is about what is going to be the problem first for the downstream firm. So we're gonna do a little bit of, I don't know, maybe we can think it about as backward induction. Certainly on time, it is more logical that the product is first manufactured and then sold by the retailer in the stores. So let's do a little bit of backward induction, and we will first solve the problem of the downstream firm. So for the retailer, for the downstream firm, what he wants to do is to maximize profits, and profits are a function of price. So price depends on the quantity, on the demand, on the inverse demand function, because I have monopoly power here, times the quantity of goods that I'm going to sell. And then the cost of purchasing these goods is the price PT. So this is the price that I'm going to pay to the manufacturer, times the number of units that I'm going to purchase, right? And the first order condition for this should be alpha minus 2 beta Q, which needs to be equal to PT. This is the price of the or well, you can think of this as a demand function, right? This relates quantity to prices and is basically the quantity that the retailer is going to ask from the seller as a function of prices. I just want you to notice the following, is that the demand function here, the inverse demand function here, is just the demand function of the consumers with twice the slope, right? So if I do this in a graph, it's good. If I do this in a graph, here I'm going to put money, here I'm going to put quantities. So at an intercept alpha, I will get, let's say, it's too much. I will get the demand. This is the demand. Oh, this is the demand of the final consumers. And then with half the slope, I hope that is kind of half, with half the slope, what I have is the demand of the retailer. Right, so this is the demand of the retailer, and it's just half of it. And this implies that by anticipating this, the manufacturer the problem is to maximize profits again, but here I'm going to take into account the demand of goods, the inverse demand of goods of the retailer, which means that the first order condition of the retailer is the demand function for the manufacturer. And then I have a marginal cost, C of producing. Which means that the first order condition, the first order condition is going to be alpha minus 4 beta Q must be equal to C, right? And so if I want to draw this, the marginal revenue of the manufacturer is going to be, again, half of with a slope that is 2 times as steep, right? And this is I don't have a lot of room. This is so wait. I don't know what I put here. This is not correct. So this function is alpha minus 2 beta Q, and this function is alpha minus 4 beta Q. Yes? For the moment, is that clear?
Yes, Joaquin, it's clear.
Right? So you see that here the marginal, so the marginal revenue of the retailer becomes the demand in the inverse demand function of the manufacturer, right? And so if you do this very carefully, it's pretty easy. So with a constant marginal cost, what you're gonna get is no. With a marginal cost, you're gonna get so marginal costs, let's say it's like this, it's constant. So this is marginal cost. So what should happen is that the retailer, sorry, the manufacturer is gonna equalize the marginal cost to his marginal revenue, right? So this is the second one is the margin. So this is the marginal revenue for the upstream firm, and this is for the downstream firm. So the quantity that is going to be produced is going to be this one at this point, which means that if I produce that quantity, the price paid by the retailer is going to be PT here, right? So this area, this area represents the profit. Let me do this in one stretch. This area represents the profit of the manufacturer. And then at this quantity, the price to the final consumer, is going to be this one. This is the price for the consumer. And so you're gonna get that this is the profit. This area is the profit for the retailer. So we can solve all these things. We already have the conditions. Now we just need to solve everything. So what do we know? We know that the quantity that is going to be solved. So the quantity at equilibrium, which is the same for everyone, is going to be alpha minus C divided by beta. You know that you always have this structure, and you have this divided by 4, right? So this is the total quantity that is going to be produced, which depends positively on the intercept of the demand function, which depends negatively on the marginal cost, as you would expect, and which depends negatively too on the slope of the inverse demand function, right? This is the inverse demand function. So that means that if beta is larger, this is flatter. When you look at the regular demand function, which is Q is equal to alpha divided by beta minus 1 over beta PT, you see immediately why larger beta means less demand for goods, right? So beta is inverse to the demand for goods, and that explains why I have this form here. Then what else can I do with this? I can look for the price, the transaction price between the manufacturer and the retailer, which is the price between the two is defined by alpha minus 2 beta. So always be careful with this. Alpha minus C for beta. As usual, the betas are going to cancel each other out. I'm going to get a half here. So this is alpha minus half an alpha. This is half an alpha. And then I get plus half a C. I'm going to factorize this by right. So I got the price. I've got the price for the transaction between the retailer and the manufacturer. Given this, I can also compute the price for the final consumer, and the price for the final consumer. Well, it should be. Let's compute it anyway. So the price for the final consumer is alpha minus beta, alpha minus C for beta, which is, so the betas are going to cancel each other out, and I get alpha minus a quarter of an alpha. So this is three quarters of an alpha. And I also get plus a quarter of a C. So you see that the price for the consumer is always going to be larger than the price for the manufacturer, obviously. And how can I see that it's always larger? Obviously, I would expect alpha to be larger than C. If not, obviously, it's so costly that no one is going to buy the product. So obviously, I need this condition to hold. And if you see what I have here is a linear combination between 2 points. And in this linear combination, I'm closer to the highest point than here that I'm in between the two points. Yes? In terms of profits, what is the profit of the downstream firm? So the downstream firm is gonna receive a price of 1/2 of alpha plus C, and he's gonna pay C to produce each unit that he produces, and he's going to produce alpha minus C divided by 4 beta. So this is, if I am correct, so this is gonna be half. So this should be alpha C divided by 8 beta. Please tell me if I'm doing something wrong. I think I'm okay. And the profit for the upstream, oh, sorry. I'm doing things incorrectly. So this one is the, so this one is the upstream firm. This is correct. And this one should be the downstream firm. And for the downstream firm, what do I have? I have the same quantities. The prices are different. So the price for the final consumer is 3/4 of alpha plus 1/4 of C minus the price of purchasing to the manufacturer. This is half an alpha. Oh, sorry. Half an alpha minus half a C. Alpha minus C for beta. And I think this doesn't look very nice. So I've got a 3/4 of an alpha minus half an alpha. So this is a quarter of an alpha. I have a quarter of an alpha. Then I got a quarter of C minus half a C. So this is 1/4 of C. And this is multiplied by alpha minus C For beta, oh no, it looks nice. It's okay. So it's gonna be alpha minus C, 16 betas.
In the benefits, isn't it alpha minus C squared?
In which one here?
The downstream. Yes.
Yeah, because I'm
Because if
multiplying,
you-
I'm multiplying them together. Yeah, of course. Yeah. Yeah, you're absolutely right. Great. Okay. So so this is the computations. It's okay. It's not that complicated. What is important maybe is to think what would happen if we have vertical integration. That is, what would happen if instead of having two firms, I have that the firms integrate and they become only one monopoly. So let's say that one firm that there's the same firm does the manufacturing and does the retailing. And if this is the case, what we should expect is that instead of having this double marginalization, what I have is that the manufacturer takes into account not the demand of the retailer, because there's no retailer, but takes into account the demand of the consumers. And if that is the case, then I would have that a monopoly that is integrated, that takes into account both, is going to produce at the point at which marginal revenue derived from the demand in the market is equal to marginal cost. And that is going to give me this chunk, no, this quantity, this price. So notice here that two things happen. First, the consumers are happier. They are happier because the price goes down. Second, well, if it's the manufacturer that I'm looking at, he's also happier. But actually, by merging both of them, I can show, and maybe we can do that, I can show that the red rectangle, it looks like a square, but it's probably a rectangle. The red rectangle would be more than the sum of the profits of both. So actually, everyone loses from this double marginalization, right? From the fact that you have two times, we're taking into consideration the fact that each time that I am selling into the value chain, I am equating the marginal cost to the marginal revenue. That is, by trying to maximize my profits, I am restraining production all the time, trying to increase prices. And the more levels I have in the value chain, this problem gets worse. I think you have already the intuition. You see that with two firms, what happens is that the marginal cost of the downstream firm becomes the marginal revenue of the upstream firm. And if I have three firms or four firms, what I'm going to have is that these curves become at each point more vertical. And at becoming more vertical, you restrain more the quantity produced, which has negative repercussions for the price to the consumer and has negative repercussions for the profits of the firms. So this is not desirable. Is that clear?
It's clear, Joaquin.
Yeah. Okay. So double marginalization is a classical problem in microeconomics. Double marginalization has this issue or creates this issue in which by having a sequence of monopolies related in a value chain, given that each monopoly is trying to increase its profits, each monopoly is restraining the quantity, right? Again, the marginal revenue of one is going to become the demand function of the other. And by this mechanism, you can get that if all the segments or all the firms in your value chain have too much market power, so we're taking the simplification that it's just monopolies, but maybe you have some oligopolies or things like this, having little competition in a sequence of firms is really undesirable. It's even worse than a monopoly, right? So this is important, and it shows you that from a social point of view, from the point of view of the firm, and from the point of view of the consumer, it would be better that things are integrated, right? So there's an economic argument in favor of having vertical integration, that is that suppliers and producers merge. And there are other arguments why integration has benefits, right? So integration has benefits. We're going to see that there's also costs. With this argument, you would say that what we should have is just one big company that rules everything and not a sequence of different companies in the value chain. And we're gonna explore a few arguments of why this should be, right? So this is the main technical part that I wanted to make. Oh, so just let's compare the profits with the monopoly. So just to be complete, if I add the profits, so if I'm adding these two things, what I would get is alpha minus c over beta squared. So this is common to both. This is 1/8 plus 1/16, right? Because those two terms are common. So this would leave me with 3/16 of alpha minus c beta. So this is the aggregate profit. And if I have a monopoly, if I had a monopoly, I would have that this monopoly is maximizing the demand with the cost, which gives me a first order condition, which is alpha minus 2 beta q minus c, which tells me that the quantity produced, so the quantity produced would be alpha minus c divided by 2. The price produced will, the price to the consumers would be, so this is half, I think the price, I need to do the computations. So this would be alpha minus beta, alpha minus c2. So this is, I need a beta here, right? So these are going to cancel each other out. I have this is okay. So I'm gonna have half an alpha. I'm gonna get half an alpha minus, no, sorry, plus half a c. And finally, I can compute profits. So profit for the monopoly is going to be 1/2 of alpha plus 1/2 of c minus c multiplied by the quantity, which is alpha minus c to beta, which will give me alpha minus c squared beta divided by 4, which is 1/4. 1/4 is equal to 4/16, which is larger than 3/16, right? So if so, in effect, the profit, if I had a monopoly, is going to be larger than the summation of the profits for the two firms. Yes? Easy?
Yes, it is quite clear.
Okay, let's take 10 minutes and then I'll come back for other stuff. Okay, so let me just bring forward. So this is chapter 10. This is chapter 10. This is vertical integration and transaction costs. Vertical integration and transaction costs. And so I'm gonna do mostly an explanation. There's not many mathematics here. So I want to do this. I want to make things as simple and as clear as I can. And obviously, again, don't hesitate to ask any questions if a concept is not clear. So there's a big literature, there's a big debate about one very simple question, that is make or buy, right? Is the question of, should I produce myself a component for my for whatever I'm producing, I'm selling, or should I buy it to another company, right? And this actually is very related to the question of why shouldn't we have complete vertical integration of the whole supply chain. So we saw in the previous example, or in the previous case, that vertical integration makes sense both for private companies and for consumers, mostly if you have imperfect competition, which very often you do have imperfect competition. If you have perfect competition, then there's not too much of a problem. But as I just argued, and it's not recorded, if only one part of the supply chain is not competitive, then you're gonna have increased margins. Potentially, the enterprise with increased margins will be able, with the profits that it generates, to acquire other parts of the supply chain and then to grab considerable market power, right? So given those arguments, one would expect that you have just one big company that is completely integrated for the whole value chain, because in this way you avoid double marginalization, and by avoiding double marginalization, you reduce substantially the costs all along the value chain. You put closer, or let's say you have a direct relation, a direct difference between the consumer price and the marginal cost of production, and this allows to generate larger profits for the company and generates better conditions for the consumers. So so the question is why this doesn't happen more. Why do we have separated businesses, right? So one argument, and so there's many different arguments. One is basically the main question is related to economies of scale in inputs provided by suppliers. And the idea is that, I don't know, I need to buy some component I am making shoes and I need to buy leather for the shoes that I'm producing. But the thing is that you have important economies of scale in the production of leather. So I'm gonna put here I have money, and here this is the market for an input, right? So this is something that I need to buy from a manufacturer, from another producer to get into my own production. And with economies of scale, what you have is that if your economies of scale are very important, you get that your marginal cost is always decreasing. Marginal cost is always decreasing. Marginal cost is decreasing. Actually, the definition is with average cost, right? But you know, or maybe you remember from micro, that if you're right, so this is average cost and this is marginal cost. This is the typical form, and we know that if average cost is always decreasing, so if average cost is always decreasing, marginal cost is also always going to be decreasing, right? So if marginal cost is decreasing, or I have a constantly decreasing marginal cost, I have interesting economies of scale, and then I have demand. I have demand for the goods. Use a ruler. I'm gonna play a little bit more with this. So this is demand. So this is demand of the sector, right? So this is all the other retailers, if you want, that are going to say to sell the same good. Let's say something like that. So I have a bunch of companies that are competing with each other that want to purchase leather. So I also have other shoemakers. Maybe I have hat makers. Maybe I have jacket makers. Maybe I have seat makers. Whatever. I have a lot of companies that are bidding for the same market, that are looking to purchase leather. And I have a monopoly in the distribution of leather. And most importantly, marginal cost is always decreasing and average cost is always decreasing. This can become a natural monopoly, right, for some particular reason. And in this case, I would have my marginal cost and my marginal revenue, sorry, is going to look something like this. This is my marginal revenue. And this is and here I have demand, right? So what we know is that the seller of the input, the seller of leather, is gonna fix quantities where marginal revenue is equal to marginal cost, and I'm going to have a difference. I'm going to have an important margin, a difference between marginal cost and the price of the intermediary goods. Let me improve a little bit on that drawing. I think that's better, right? So if I am purchasing these inputs as a retailer or as a manufacturer of shoes, and I need to buy an intermediary good, and I need to decide on whether I should produce my own leather or try to buy it with the other company, what I should basically check is what is the cost for the what is the cost for me of producing. So if I need small units, if I need small units of leather, let's say this is what I need for firm I. This is what firm I needs, and it needs a tiny quantity. So I'm going to use a ruler here, and I need a tiny quantity. Let's say this quantity. I know that producing it myself is going to cost me this, and I know that buying it on the market is going to cost me this. So basically, because my production is sufficiently small, it's too expensive. So it's going to cost me this in the sense that I can, the technology is freely available, right? So if it's a company that is working with leather, I don't know, the technology is known, it's very old, everyone know, well, it's really relatively easy to adopt the technology to do it. But because the scale of the production that I need is so small, the marginal cost of doing it is going to make the price of producing it myself larger than buying to the monopoly, right? If instead I need a sufficiently large amount, of leather, then in this case, to produce it myself, it's going to cost me this. The price of purchasing it on the market is going to be this. So in that sense, to me, it's more interesting to make my input myself than to purchase it from the firm. Right? So this means that one of the reasons why we should expect that there is no vertical integration, that not the whole supply chain is not within one company, is that some of the inputs have important economies of scale. That is, they become cheaper as I produce more. If they do, doing it myself is going to be very expensive, and it's better to have a company, an outside company do it, which is going to make more volume, that is going to be sold to more companies. And even if it's a monopoly, even if it's pricing by equating the quantity to the marginal revenue to the marginal cost, even if it's a monopoly, it might be better to have a monopoly in the supply chain than to do it myself, to integrate in the production if there's a big difference between the volumes that I need of the input and if I have important economies of scale. Is this clear?
Yeah, it's clear, Joaquin.
Okay. So one first argument for not having vertically integrated firms is that probably the volumes that I need of the input are just too small to justify producing it myself, right? And if I don't know, if I'm making sandwiches and I'm gonna put toothpicks in my sandwiches, it's probably a really bad idea that my sandwich restaurant is gonna start making toothpicks, right? So it's better to just purchase this somewhere else. And so this is the first argument. However, there is reasons again to vertically integrate that go beyond getting rid of double marginalization, no? In particular, if I have a competitive setting. And the reasons for vertical integration, I'm gonna list them. I'm gonna list them here, and it's 4 main arguments that I think are really important. So this is the question. This is the answer of the question. Buy or make. So the answer is going to be buy, obviously, if it's an input for which I need a small quantity and there's important economies of scale. And you can imagine that this is very frequent, right? To do toothpicks, probably the marginal cost is incredibly small. So you have large economies of scale in making toothpicks, and no one is going to do toothpicks on their own restaurants. It doesn't make any sense. No, and this is I think a very illustrative example of other things that can happen. However, when we take the decision of why making Why make at home? I know this is not good English. Let's not put it like that. Let's put it why vertically. Why should we vertically integrate? Why should we vertically integrate even with competition? So the first argument was when there was small or no competition, integration is worthwhile to avoid double marginalization. And even if the markets are more competitive than that, you can have a lot of problems with having to deal with other companies. So there's 4 arguments. The first one is related to coordination. And this is something that is, I think, very familiar to all of us, at least in Bolivia. That is that my supplier fails, or he gets late, or the quality is not good, or things like this. So obviously, if I have a direct relation with my supplier, if I am my own supplier, or at least if one of the employees is my supplier, then it's much easier to implement coordination, right? One of the reasons I would prefer to do something in-house, to produce something in-house, is that the person in charge of producing this good is under my orders, and he receives a wage, so I can basically instruct whatever that is legal, but I can instruct whatever I want because I'm the boss. So this facilitates coordination. While if I have a commercial relationship, unless I have a very detailed and complicated contract, then I have these mishappenings of late deliveries, of low quality being produced, or incomplete deliveries, or things like this. But again, competition in the market can help with that. I can always change my supplier if he's not doing a good job. But again, switching and looking for another supplier can be costly, right? Because I need to search for another guy. So this creates a series of problems, right? Another reason why I would like to vertically integrate with some parts of the production chain, of the value chain, is what we call proprietary knowledge. That is, I want to keep information, if not secret, at least reserved information. I want information about, I don't know, how many components I'm gonna use, what is my human resources management strategy, what is my marketing strategy. If I So my connection isn't stable. If I subcontract too much of these activities, my information is gonna go outside. It can be diffused to others. For example, if I have someone outside of the company that is in charge of recruiting personnel, it might be that other companies are also contracting or subcontracting this human resources company, and then the human resources company, his interest is to get well paid, so maybe he puts human talent with my competitor. So I want to keep human resources management in-house. So there's a lot of arguments of why I would like to keep things in-house, in particular related to keeping knowledge close to home and avoid the knowledge to move around, right? So related to coordination problems and proprietary knowledge is what we call transaction costs. Transaction costs. And transaction costs are actually something very important because transaction costs can explain why some firms use some types of organizations and why some others don't. Why do we have vertical integration or not? It can explain the size of the firm. It can explain the contract, the type of contracts that are going to be within the firm, right? So transaction costs include problems like, you know, drafting contracts, also negotiating contracts, right? So it's gonna be expensive for the firm to hire a lawyer. It's gonna be expensive to spend hours and hours negotiating the terms of the contract with my potential supplier. So it could be that it's just better to produce myself whatever I need, because then I don't need such a complicated contract. Maybe I need just a labor contract with whoever is going to produce the thing in my firm. And I don't need to be so specific. I don't need to be so specific with contracts, right? Another transaction cost that is that has an important impact is searching. Again, if I need to use a supplier that is outside of the firm, if I need to contract a third party, I need to look for the ideal third party. This could take time. It could be difficult. Maybe I have already a subcontractor, but this guy let me down, or he was not coordinating with me. He was late with deliveries or whatever. So I need to look for another guy that is able to do this. And so this can also take a lot of time, and maybe it's better to have already someone under contract that I can monitor and control better than having to search for new partners all the time. And the other monitoring cost that is important is monitoring costs. Monitoring costs, if I need that work is done with a lot of care, with a lot of detail, I need to check the quality of the product, and the quality of the product is very important for my market strategy. It's gonna be very expensive if I have to go see how my supplier is doing its job, right? If I need to go to the factory of the supplier to see if he's taking appropriate care, if he's doing things with care, whatever, it's going to be costly to go and monitor all these activities all the time. So it's also maybe better to just have this guy under my control, and this might allow me to verify that he's taking care on what he's doing, right? And what is very important here is the fact that all these things require monitoring, searching, verifying for quality. What they need is, if I decentralize, what I need is a very good contract, right? I can solve the problem of quality of monitoring if I have a very, very good contract which states exactly what is going on with the quality process, that allows me to monitor whatever is happening. If I see faults, or if I see errors in the production process, I can always use the contract to punish the other part. But sometimes, or very often actually, you will have unforeseen events that happen, events that are outside of the scope of the contract, right? So we talk about a problem of incomplete contracts. Right? So when contracts are incomplete, is that there's events that are not anticipated in the contract, right? I don't know, I had a supplier of leather, but all of the employees got sick because of Omicron, and this was not in the contract because we did the contract 5 years ago when we didn't know anything about coronavirus. So there's some unforeseen circumstances, and the contract is not going to allow me to protect myself from these circumstances. So in this case, instead of having a contractual relationship with the supplier, it might be better to produce whatever I need in home, so that the kind of contract is not a supply and retailer contract, is not a supplier and retailer contract, but it's a laboral contract. And the laboral contract, again, to my employee, I can ask a lot of things. There's a hierarchical structure. No, there's some, obviously I cannot ask him to do illegal stuff, but I can ask my employee to do a lot of different things that are not exactly contemplated in the contract. And therefore it's worthwhile for these cases where there's a lot of contracts incompleteness, in where there's a lot of searching and monitoring costs, in where quality is very important, to do things in-house, right? And so this is the counterpart of buying stuff instead of making it myself, right? And finally, a last argument, and this is a very subtle argument, is an argument related to asset specificity. And this is a branch also of industrial organization that is very important. And so in this branch, in this problem, what happens is that I have a supplier, and the supplier needs to do a machine for my factory, let's say, right? And what is important is that this machine is specific to my factory. That means it's a unique machine. There is not a good substitute in the market. The machine has been manufactured specifically for me, right? And then I can, the problem for the producer of the machine is that the producer of the machine, when the machine has been fabricated, he has already gone into the costs of producing the machine. I can go to look for my buyer, and my buyer can tell me, oh, sorry, I don't need it anymore. I don't need this machine anymore. I'm not interested in it anymore. I found a better solution. So either I don't want it, or I want you to reduce the price substantially. And the problem is that because the asset is so specific, and it's only available for one company, or it just matches the needs of one company, the maker of the machine has no other potential buyer. So no one is competing for buying this thing, which means that the value of the asset drops drastically outside of this transaction. And because it drops drastically outside of this transaction, so the buyer, the intended buyer, can renegotiate the contract, in particular when it's very difficult to specify the characteristics in the contract of the machine. So if the contract is incomplete, I cannot write exactly what is going to be in the machine. And the buyer tells me, look, this, at the end of the day, this was not what I'm looking for. So I will ask you to reduce the price drastically, even to the point that the price could be lower than the production cost, because it's better to sell for less than the price than not sell it at all. Therefore, anticipating this, the maker of the machine is not going to make the machine, and the market is not going to work. There's not going to be a transaction. This is known as the hold-up problem. This is known as the hold-up problem. So it requires, again, it requires incomplete contracts. It requires incomplete contracts. It requires asset specificity. That means that the asset only has value for one actor in the market. Any other actor in the market doesn't care about this asset or doesn't find that there's value about this. And then again, the mechanism is that once the machine is produced, when the specific asset is made, given that there is incomplete contracts, the intended purchaser of the asset can tell me, I am not satisfied with what you produced, even if it's not true. Even if the machine is perfectly good, I can always have an opportunistic behavior, what we call opportunistic behavior, in which I lie by telling the other guy, I really don't care about this machine. I know that you don't have any outside option to sell this machine, so I'm going to renegotiate the price. I'm going to renegotiate the price downwards, obviously. And because the manufacturer of the machine has no other alternative, he has to take this lower price that can be even lower again than the production cost. So by anticipating this, by anticipating that there is no complete contracts, that is very hard to specify all the characteristics of the good, but also by realizing that the asset is very specific and that no one else than the buyer would want it, I anticipate that the buyer is going to take an opportunistic behavior and try to reduce the price given these conditions. So anticipating this, I am never going to produce the machine. And so all these kind of assets are not made. Is that clear?
Yes, it is clear.
Great. So if you understand this, you understand something that is very important, because try to apply this to things that you see around in your life, and you will see that this explains a lot of the things that happen, right? So this is I think this is a very, very important phenomenon. There is one bit of terminology that I need to add, which is called quasi-rent. Quasi-rent. And so the quasi-rent is the difference between the intended, let me use exactly the same vocabulary, the difference between the expected price for the seller and the actual price, right? And the actual price. And then so you get, there's a rent that is given to the buyer of the asset if the asset is produced, because we first negotiated a contract and I told you I'm going to pay you 100 for this. Then I see the product and I'm not satisfied, and I tell you, okay, I'm going to pay you 10 for this thing. So I'm going to get a quasi rent of 90, because this is the difference between what was agreed in the contract and the price that ends up happening in the renegotiation. So solutions for this problem, it's either you have a good contract, but having a good contract might be difficult. It might be not possible to have a good contract because you cannot specify all the details of the product, because there's things that you cannot foresee or not anticipate. And the other is, again, vertical integration. What I do is, to get rid of this problem, I vertically integrate. I buy the company that makes this a specific asset. So in that way, I know that they cannot screw up, because now it's not a commercial relationship. It's a hierarchical. Sorry, I don't know why it's so hard for me to say that. Hierarchical relationship, right? It's a labor relationship. So basically, because I'm your boss, I can be sure that these kind of things don't happen, right? Because I'm not paying you for the product, I'm paying you a wage, maybe with some incentives, but that's another story. So other kinds of solutions, there is a few points that are made in the subject guide. So alternatives to make or buy. So your decision of making or buying might not be such simple. You might have additional figures that are possible. For example, joint ventures, where you put assets, physical assets together between two companies, and then you divide profits as well. So it's not exactly integration, but it's, let's make a temporal contract where we get together to produce a thing simultaneously, sharing an asset. So that's one possible way of doing it. The other one is, if I have a network of suppliers, to have a good relationship with my network of suppliers. So if I have a long-term relationship with confidence between each other, with reputation mechanisms, that can impact from one supplier to the other. So I have two suppliers, and if I betray, or if I ask for a lower price than was agreed with one of the suppliers, the other supplier is going to find out, and he's not going to be willing to do business with me. Mostly if I had a lot of suppliers and I get a bad reputation with one of them, this can repercute on the network of suppliers. And so social networks, reputation, confidence, trust, all of these things can help attenuate the problems that I mentioned earlier. And also I can always do a mix in which I do integrate some part of the production in my firm. I produce some of my inputs, but maybe I get a lot of fluctuations and I need more volume than what I can produce. So maybe I will produce a part of my inputs and then I will purchase the other part. Obviously, the advantage of buying inputs to another firm is that I can accommodate fluctuations in demand easier, no, in an easier way. Good. I'm gonna leave the recording up. Right, so the last thing I want to show you today is what it's models of collusion. And the guide uses and Don mentions it, or at least I haven't seen it. Maybe I have to read a little bit more carefully. They use something that is called repeated interaction, or maybe more specifically something that is called the Folk theorem in game theory. So suppose the following setting: you have two firms, and they compete on prices. Two firms that compete on prices. So I know that if they are competing on prices, Bertrand Competition predicts that they're gonna charge at the marginal cost, so that price is gonna be equal to the marginal cost, and so that no profit is gonna be generated. So I'm supposing that the firms are symmetrical, and we can do a matrix. A matrix payment in which there is collusion between the two. That means that they agree on fixing a price. They agree on a price. This is not legal normally, but let's say that they manage to make an arrangement between the two so that they charge a price, the monopoly price, right? So let's call them firm one. Let's call it firm two. And they have two set of actions. Then they can collude. They can collude, or they can betray. They can collude or they can betray. If they collude, so they both set the prices at monopoly price, and then they get, each of them, they get half of the market. So the payments for each of them is the profit of the monopoly divided by 2, because they are sharing, they're splitting the market in 2 parts. If firm 2 betrays firm 1, so that he asks for 1 cent less in the market price, so I just do a very marginal, tiny reduction on price, so small actually that it's barely noticeable, but sufficient to keep the whole market. So I'm going to get the profit of the monopoly, or could be a little bit less than that. It's not very important. No, but I'm asking 1 cent less by product, and suppose that this difference is negligible. So the only important thing is that I keep the whole market, and firm 1 then loses everything. He wanted to cooperate. He wanted to keep the agreed price, but then he got the whole market stolen from him. Things are symmetrical, so if it's firm 2 that decides to cooperate, he gets a payment of 0, and if firm 1 betrays the other firm, he gets a payment of PM. And if they betray each other, basically, if you get the Nash, the Nash solution, so the Bertrand solution in this case, in the Nash equilibrium, you will get a payment of 0, right? If they do Bertrand competition, right? So this is the structure of the payments. Is that clear up to this point?
Yes, it is.
Great. So let's say that they have the 2 firms enter into an agreement, and the agreement, so they collude, and they said, okay, let's collude, let's cooperate. If you betray me once, I will never collude with you. I will never cooperate with you anymore, right? So this is what is called the trigger strategy. La estrategia del gatillo. And the trigger strategy is the following: if you betray me, I will never cooperate again, right? And if this is the case, at each point in time, so this is a repeated game, right? This is a repeated game. That means that I don't know, let's say each month or each year, they have to choose their policy, their price policy, and their price policy can be either to collude, to actually ask for the price that a monopoly would ask, or maybe I betray the other player and I ask for a little bit less than the monopoly price, in a way of capturing the whole market. It's a repeated game. And I suppose also that I have a discount factor. I have a discount factor delta. That is, this is the value that I will give to future. So this is a discount of future values, right? So if you give me 1 Boliviano in the next period, the value for me of this 1 Boliviano is delta. And if you give it to me in 2 periods, then the value is delta squared, right? So obviously for those in finance, this is super easy. And the idea is that if I cooperate forever, no, and if we manage to cooperate forever, what is going to be the payment? The payment is going to be the first period that we cooperate, I get half of the profits. And then the second period I cooperate, I get all of the profits, but I have to take into account that it's in the future. So I discount it by a factor delta. Then in 2 periods, I keep half of the market. And in 3 periods, I keep half of the market. And this goes on forever, right? So it's a repeated and indefinite game too, right? So you know by financial mathematics that I can write this down as 1/1 minus delta PM over 2, right? Because it's a sequence, it's a sequence, and because delta is between 0 and 1. So this is the expected payoff. This is the expected payoff of the firm if it colludes and if both firms keep on cooperating forever. If instead, if I betray the other firm, what is going to happen? What is going to happen is that in the first period, I capture the whole market. I capture the market altogether. And then in the future, I get 0 because the other player is playing the trigger strategy. The other player is playing the trigger strategy, and therefore I know that my earnings are going to be 0 for the rest of time, right? So I need to choose. When I need to choose at each period if I want to keep cooperating or if I want to betray, I'm gonna choose if it's better to get a steady stream in all periods, or a discounted stream of profits of half of the market, and I'm going to cooperate. I cooperate if this is larger than betraying and keeping all the profits, but this is going to happen just for 1 period, and then all the subsequent periods I get 0. Is that clear?
Yes, it is.
Good. Have you seen this before? I know Joaquin has.
Yeah, I have seen it too.
Okay, so this is an application of what is called the Folk theorem. That maybe I'm gonna put the Folk theorem in words in a moment. So this also, there's a little bit of math involved here, but basically this tells me that delta needs to be larger than 1/2, which means that you can expect a cooperative outcome if players are playing the trigger strategy. You can expect a cooperative outcome if, let's put it like this. You can expect a cooperative outcome if the discount factor is sufficiently high. So if my discount factor is larger than 50% or than 0.5, then I am not too impatient. I value the future enough so that I want to sustain a collusive cooperative relationship, and then therefore I will cooperate, right? So at each turn, at each sub game, it is a dominant strategy to cooperate if delta is sufficiently large. And then we have what we call a sub-Nash perfect equilibrium, which is an equilibrium in which cooperating is better than non-cooperating for all the periods. So for the infinite stages of the game, it's a best response to cooperate. It's actually a Nash equilibrium that both cooperate if the discount factors are sufficiently high. And it's also for each sub game, it's an optimal strategy. If not, if my discount factor is too tiny, then I don't value the future enough. That means that I prefer short-term gains more than a stream of smaller gains on time. And in that case, my dominant strategy is going to be to not cooperate. And then no cooperation can emerge in this case, right? Just a pair of extensions, just a couple of extensions. The first one is what happens if we have more than 2 players? So in this case, so my matrix is not going to work, but basically the idea, if I have more than 2 players, is that I cooperate if so the stream of winnings, which is divided here by the number of players, right? Because I'm making a collusion with a numerous with several players, right? So I have many enterprises that are colluding with me. So we're gonna divide the profits among the N companies, and I am willing to cooperate with these N companies if this is better, again, than betraying everyone. And if I betray everyone, I keep the whole share of the market. I get 100% of the market, and I want to see which one is better. Again, there's a little bit of math here, but basically, if you solve this thing, what you're gonna get is that I'm willing to cooperate if my discount factor is larger than this. You can check the math. This is gonna be the result. So this tells me that if you think about in terms of limits, this thing is increasing in N. At the limit with N, when N tends to infinity, this will tend to 1. So this tells me that if competition becomes more intense, if I have more firms in the market with whom I need to do collusion, collusion is going to be much harder to sustain. I need a much larger discount factor, which makes sense again, right? Because my discount factor tells me how much I value the future stream of payments that I have to divide among more players. And given that this future stream is going to be divided among more players, it's going to be a smaller stream, and maybe it's going to lose value compared to betraying everyone and keeping the large profits for just one period. So if I want to maintain collusion, if I want to maintain cooperation between the firms, between competitors, it would be necessary to have a really high discount factor. And the more competition there is, the higher the discount factor needs to be to maintain cooperation. Yes? Clear and easy?
No.
Okay, and the last one, the last extension is, what if the strategy is not a trigger strategy? So we define the trigger strategy like, if you betray me, I will not cooperate with you again, never again. And maybe we can have something that is a little bit more flexible. And I could have something like, if I have like, I can forgive you. Now suppose that the strategy is I forgive, I forgive punishments for 2 periods, let's say. That is, if you betray me today, I will not cooperate with you for 2 periods, and then I will try to reestablish a cooperative agreement, right? And so we can model this in the following way. So I'm going to keep this with two firms to keep things simple, with 2 firms. So what would happen if I cooperate? Again, I cooperate. If this happens, then again, this is if the stream of payments, if we cooperate, is steady, no changes there. And on this side, I will have that if I betray you, I get the monopoly, all the profits from monopoly power, the first period. Given that the first period I betrayed you, you punish me, so I can expect that in period 2 I get 0. I can expect that in period 3 I get 0 as well. And finally, I will have, and finally, let's say that we reestablish cooperation from the 3rd period on. So here I need to be a little bit careful because this is a stream of an infinite stream of cooperation in the future, but I have to discount this from period 3 on, right? So maybe just to make it a little bit easier to understand, it's again an infinite stream of money where we cooperate again, but I have to take it into account from period 3. Yes, does it make sense?
Yes, yes, it makes sense.
Okay. Given that I want to solve, it's a little bit hard. I want to actually get rid of this thing. This one is a little bit annoying. So what I can do is rewrite the first part, in which the first part I can write it like 1 plus delta squared, the profit of the collusion, plus the continuing stream. So the continuing stream is 1 minus delta 3 PM over 2, right? So this one and this one are the same. I'm just disaggregating. I'm decoupling this so that I have an expression that is similar in both sides of the equation. So this is a neat it's a neat trick. It's important to think about it, but it's once you know the trick, is not too complicated, which will allow me obviously to simplify these 2 guys. And then I will end up with, I need to solve something like 1. Oh, I'm gonna go back to black. I need to solve something like 1 plus delta. Okay. 1 plus delta squared. The profits divided by 2 needs to be larger than PM, which can simplify, and I need therefore and I need therefore something like I need to solve for 1 plus delta squared needs to be larger than 2, And so I have a quadratic. I should find two solutions, one that is going to be negative and the other one that is going to be positive. I'm not going to do the math here. We can use a calculator if we want. And so what is important is that delta will need to be larger than 0.618. So this is the example of the book. And why is this important? Because it tells me that if I want to maintain cooperation, when I had the trigger strategy, I needed a discount factor of 1/2. If I have forgiveness, I will need a discount factor that is larger than 0.661, which is obviously larger than 1/2, which means that if there are problems of commitment, that is, if you betray me and then I forgive you afterwards, it's going to be much harder to sustain cooperation. Cooperation would require higher discount factors. No, I need to value more the long-term relationship to keep on cooperating. But if I do forgive you, if I don't have such a rigorous and strict policy as the trigger strategy, cooperation is going to be more complicated, right? So I always use the example of personal relationships. No, if you know a couple, you always have these couples of boyfriend and girlfriend, and they're on and off together. Once again, they end up and they come back together because of the forgiveness, the anticipation of forgiveness. Then it's less likely that you have long-term cooperation, right? If I can credibly tell you, okay, if you cheat on me again, then I will never talk to you again and the relationship is over, then this is a much better strategy, if it's credible, to avoid cheating and to maintain cooperation than if you cheated on me, but I love you anyway, so let's come back together, whatever. So this creates obviously really bad incentives to cheat again, and this creates probably makes long-term cooperation more difficult, right? So this is useful advice. This is useful advice for other matters than industrial organization. Good. It's okay. Do you have any questions on this?